All right, everyone. So today what I want to talk about is how to actually read the NETA book and follow some of these maintenance procedures. So the first thing I'm going to say before we get into all of this is read the bleeping manual, okay? There's so many checks in these books that require you to refer to manufacturer specifications, and if you're not reading the manual, you're not doing your job. It's just, I'm sorry, someone's got to tell you, and it'll gladly be me, to be honest, okay? You got to do your job and you got to do it how the book says, or you're not a NETA tech. So let's go over how that looks. Okay. Now, before you read the manual, there's another specification that is ultimately the first one, and that's your customer specification. If the customer tells you and it's ethical and safe that I want you to test this standard, then that's, I mean, they're paying your bills. Who cares about what the NETA book says? Okay. Who cares what the manufacturer says? The customer's got a more stringent standard. That's what they want. Test it. Okay. You can always recommend what NETA says instead or what the manufacturer says, but customer specification is the one paying your bills. So I recommend you follow what they ask for or you won't have many customers. All right. So let's go ahead. We're going to be looking at an ABB circuit breaker here. It's a 5 kV HK ABB circuit breaker. Okay. Now this is what it looks like right here. The big old bastard. Oh, drawing on it. Don't need to be drawn. This is one of these. A lot of mechanical air moving parts on this one. Okay. So we're going to go ahead and talk about this real quick. Now, you're not going to do it in ATS, so I have the ATS pulled up here. We're actually going to go into the MTS, okay? So the MTS, you'll get to your page, and it's make sure you're reading it right. Air circuit breakers. There's several different sections that are not air. Make sure you're on air. Also, make sure you're on medium voltage, okay? Also, make sure you're on circuit breakers and not switches, because you can mix up any one of those and it'll all be wrong. All right. So there's a lot of things to check here. This is an air circuit breaker, arc chutes, right? There's a lot of mechanical devices that you need to check on here. If you read this right here, perform slow close, if recommended by manufacturer. Perform slow close, check for binding friction, blah, blah, blah. Lots of stuff to check for. Okay, contact sequence, alignment, and it says penetration. Usually what that means is pressure. When you read the books, you'll see that. In the absence of published literature, follow an IEEE doc. It doesn't even tell you, it doesn't even give you a NETA specification. It tells you go to IEEE if the manufacturer ain't got something. Okay. And then perform mechanical maintenance in accordance with manufacturer's data. All right. Perform electrical connection high resistance testing. This right here, all your torque checks in accordance with manufacturer's data. Okay, lots of stuff. It tells you that's all mechanical, right? Now let's get on to the electrical insulation resistance. All right. In the absence of manufacturers, use table 100.1. Everyone likes to just go straight to that table. You are wrong. You do not go to that table first. You go to the manufacturer's book first, and on these older circuit breakers, they're not going to have, most of them, a lot of them don't have, I wouldn't say most, but a lot of them don't have insulation resistance testing, okay? They have high pot testing. They performed high pot on all of their circuits and not too much meggers, okay? Contact resistance, you might get lucky on some of these older ones to perform contact resistance. A lot of them either have pure mechanical pressure tests, or they're going to have millivolt drop checks on the older ones. Now, the newer vacuum circuit breakers and SF6s, a lot of these are going to have your contact resistance and your insulation resistance values and minimums and stuff like that. But a lot of these older breakers aren't going to. Okay, so we're going to go ahead. We're going to look at this. You can see that there was no real high pot listed here. If you look real close, dissipation factor, perform power factor, insulation resistance on the control wiring, yeah. Perform static pole resistance check, okay, but there's nothing specifically that says dielectric or high pot. And what you're going to find is a lot of these older manuals, it tells you that the insulation resistance is the dielectric resistance, okay? And so let's go ahead, let's go to this. This is the manual right here. I'm going to scroll up to the top so you can see. Always confirm it matches your circuit breaker, or you're not doing your job. I'm sorry. You have to make sure that you have the right documentation. You can't just say, I've got a 15 HK 350. That's close enough. No, I mean, all your high pot numbers are wrong. Okay. If the second number over here, the 150, is a 250 instead of a 150, your millivolt drop checks are wrong. Okay. So you have to make sure that you have the right manual. Now, this covers several different ampacities, and we're going to go through some of these checks right here. So page 11, I'm going to scroll down to it. Page 11 is going to have our high pot values. I already went through some of this and tried to find them. So the high pot is nothing about insulation resistance. It says dielectric test values, right? That's usually a high pot test, but the problem is we don't have anything for a megger. So there you have your 60 hertz or your DC. If you look at these numbers and you compare them to the MTS high pot tables, okay, what you're going to find is they're not the same. So don't use the MTS, use the manufacturer's. Okay, I'm sorry, but it's the manufacturer's literature, and it's what NETA tells you to do in the first place. So you should be doing what the book tells you. Otherwise, you're not performing the test properly. If I see your test report, and I'll call you out on it. So, and I expect anyone to call you out saying that you're not performing it according to manufacturer specification. So this is this. By the way, this book isn't too hard to get. I just Googled it. So this is the high pot. What about insulation resistance? Well, I just told you there is no real insulation resistance. You can read through this whole book. There's nothing for insulation resistance. The closest you're going to get is this dielectric test. Okay. So the next one, let's talk about contact resistance. Like I said, on this one, there is no real good contact resistance, okay? It says that after you perform these checks over here, then you can go on to performing your contact and insulation cleaning, and then you can go on to your millivolt drop checks, okay? It says that in order to perform this millivolt drop check, what you have to do is you apply 200 amps, okay? It doesn't tell you to perform this check with, you know, 1200 amps. It tells you 200 amps, and this is what you should get. Okay, you can perform this a whole bunch of different ways, and you can say I'm going to do it with 50 amps because that's the only one I have. Okay, well then you could use the 45 micro ohm. You just have to compensate for it, but do not think for a second that when you can just skip this check and then use a contact resistance test set, right? A DLRO, and go up there and test it at 100 amps and you get 30 micro ohms, well, yeah, that's probably a good number, okay? But that's not what the book says. This is an AC test. This ohmic value right here is an impedance value, okay? And it will always be higher than a pure resistance value. So you have to understand the test that you're performing. This is a millivolt drop check. This is not a contact resistance. And it is usually going to be higher than your ohmic resistances, your pure resistance. So there's that one. There's a lot of mechanical checks, and they start on page 7 right here in this manual. Everything from gap distances, contacts open, pressures of contacts closed. I mean, you got a lot of stuff that you're supposed to check right here, okay? Main contact compression is listed right here, all right? There's a lot of things to check, and they go in and out of every single page all the way down towards the end of this book, okay? So there's a lot of stuff to check here, and all of them should be checked. The last thing I want to talk about is this one that I get asked so often, and I'm almost disgusted by how much it proves that people don't read the manual, okay? If you are asking me what your pinout on your circuit breaker is, it just proves you didn't read the manual. You didn't even open it or skim it because it's a picture. It's not hard to find. It's a drawing. It's a schematic diagram of what these are, okay? Now, just as a note for everyone, the motor is going to be an 88 or it's going to be MOT or M, okay? And then you're going to have TC or 52T or something along those lines for your trip coil. And then for your closed circuit, it's going to be a 52X or a CC, okay? And then this Y is your anti-pump relay for your closed circuit. So that way you don't sit there and pump over and over again. I mean, all this stuff's in the manual. Just asking for you to read it. This is how you do your job, right? The NETA book is just a guideline to help you get there, tell you what checks you should be performing, tells you which ones are optional if it's going to be a NETA specified test. If that's what the customer wants, then that's what you give them, right? But NETA still tells you to open up the manufacturer's book and go through it. So I hope this helps people. We're going to do 2 more circuit breakers and a set of cable just to show some more variances and differences in the systems, okay?